Hi guys, it's your guy Olumide, and today we are going to be solving another one of the most commonly asked tech interview question, climbing stairs. It's a DSA problem that's asked by top tech companies including Google, Amazon, Netflix, Meta, Apple, Microsoft and other top tech companies. The problem statement states that determine the number of distinct ways to climb a staircase of n steps by taking either one or two steps at a time. So we have a staircase of n steps and we are to take either one or two steps at a time. So how many possible times, how many distinct ways can we possibly climb the staircase by taking one, two, or both one and two step, along the way? But at a time, of course, we are going to be taking either one or two. So we can decide to take one throughout, we can decide to take two step throughout, we can decide to take one or two step, but we can always take one or two step at a time. We are given an input n, which is 4, right? Meaning that there are 4 steps, and then the output is 5. Why? Because there are actually 5 different ways whereby we can climb a staircase of 4 steps. We can either decide to climb one after the other, so all one taking one step, gently, solemnly taking the step one by one, a step at a time, right? So, or we can decide to go 2 steps at a time, right? And then go one for the rest of them, or we can decide to go one at first and go 2, then go 1 again, or we can decide to go 1, then take 1, then take a brief risky leap of 2. We can decide to take we can decide to take two step here, so we just have to take 2 leaps, fast, even though risky, right? So now we have to determine how many distinct ways. So looking at this now for a step of n, a step of 4 or a staircase of 4 steps. If we are gonna take it 1 or 2 step at a time, then we are gonna be taking 4 different ways. That we are gonna be having 4 different. I'm gonna cut you too. Now let's see how we can solve this problem. We know quite well that to get to a staircase, a step I in the staircase, in this case, let's say this is the step 1, step 2, step 3, right? So to get to a step I at any staircase, we can either get to it from the step I minus 1 or from the step I minus 2. Why? Because we can either take 1 or 2 step, right? So if we're gonna take 1 step to get, we can't take 5 steps, we can't take 10 steps, so we can't get to it anywhere below I minus 2, right? Is either we get to it just 1 step away, and we can get to it just 1 step away by taking a step from 1 step away, right? Or 2 step away by taking 2 steps. So we can always get to I either from the step I minus 1 or step I minus 2, right? So that means that what the number of ways to get to step I can be calculated from the number of ways to get to step I minus 1, which is actually, let's say that climbing stairs is a function that helps us to get the number of ways to get to a particular step. So the number of ways to get to step I can be calculated by saying that climbing stairs of I minus 1 and climbing stairs of I minus 2, like from these two opinion. Why? Because we can either get to I through I minus 1 or I minus 2. Definitely that means that considering a step of n, right, which can just be any number, it can be the number of ways to get to that step by taking 1 or 2 steps at a time is just climbing stairs of n minus 1 plus climbing stairs of n minus 2. Why? Because irrespective of how many steps we have been taking or how many step n is, we can always get to n either through n minus 1 or step n minus 2. So therefore, anything that can get us to step n minus 1, the number of ways whereby you can use to get to step n minus 1 and step n minus 2 is what will be mashed together to take us to n. So now what we're gonna be doing is that we're gonna look at how to solve this problem using recursion, right? So recursion. So we know that, okay, let's say that CS stands for climbing stairs. For these functions, climbing stairs, that's gonna return the number of ways to climb a staircase of step 6, right? So we know that from what we discussed in the logic, we can get to it either from step 5 or step 6. So therefore it means that what, to get the number of ways that can whereby we can climb up to a staircase of 6 steps, we need the number of ways whereby we can climb up a staircase of 5 steps and the number of ways whereby you can climb up a staircase of 4 steps, because these two is what can possibly lead us to the 6th step, either from the 4th step or 5th step. So similarly, these two subproblems can be further broken down into subproblems, simpler subproblems. Why? Because the number of ways that will get us to step 5 also depend on the number of ways that will get us to step 4 and the number of ways that will get up to step 3. Why? Because we can only get to step 5 through step 4 and or step 3, right? So, and similarly, step 4 also depends on step 3 and step 2, and as well step 2 depends on so now we now have to consider a base case. There have to be a case whereby it won't have any more subproblem. And then how do we get these cases? It's just by mere logic. We know that if the staircase is just 1, there is no much way in which we can climb a staircase of 1 step, right? Except by just climbing it anyway. It's just gonna take 1 step. We can't jump 2 steps for a staircase of 1 step, right? So meaning that the base case will be for 1 and 2. Why? It is for 2 because there is also limited ways in which you can climb a staircase of 2 steps, and it is just by climbing it, taking 1 step at a time or taking the 2 steps at a time, right? Meaning that if we are climbing a staircase of 2 steps, there are only 2 possible ways in which we can do that, by taking 1 or taking 2 at once. But if we are climbing a staircase of just 1 step, there is only 1 way, which is just taking 1 step at a time. So both 1 and 2 are actually base cases, right? So meaning that when we want to calculate the staircase, the number of ways to climb the staircase of 3 steps, fine, from our logic we say that we will be doing CS2 plus CS1, because we can climb 3 a staircase of 3 steps either from the second one by taking a single step or by taking 2 steps at a time, right? So which means that CS2 plus CS1. And now that we know that our CS2 is actually 2, because there are actually 2 ways whereby you can climb a staircase of 2 steps, and our CS1 is actually 1 because there's just 1 way of climbing. So meaning that CS3 is actually gonna give us 3, and then you can say that 2 plus 1 gives us 3, which is CS3. That is the total number of ways whereby you can climb the staircase of 3 steps is just 3, right? So, and why? We know very well that the number of ways to climb the staircase of 2 steps is just 2. So meaning that CS4 is gonna give us 5. So if you look at it, you see that this is a top-down recursion, or let me say top-down data structure. So the structure to navigate these 3 is actually top down. Why? Because the solution to CSCs, the solution to the total number of ways whereby we can climb a staircase of 6 steps actually depend on the lowest base cases, the lowest subproblem. Meaning that before we could get 6, we have to first navigate down to 1 and then to solve this problem upward. So that's how we call it the top down. You understand? The solution is not just getting directly from the main problem, it is getting from the very littlest sub problems. That is why dynamic programming is best to solve these problems. Okay, now that we have a good idea of what we are doing, of what we are talking about, now one thing we consider is that, and one thing we can observe is that there are some situations whereby the problem is being solved repeatedly, right? So which is actually inefficient. Consider this situation of C4 here. C4 have been solved here, right? Because one thing about it, like I said, it is top down, in the sense that it's not just gonna give you the solution to this immediately. It's going to go downward until it reaches some base cases. It will now start with bubbling up, right? So meaning that we are gonna get the answer to C4 before we get the answer to C6, and then after doing that, you see that C4 is called again right here, meaning that what we are trying to repeatedly call the same function on the same number of steps. So if we are just using mere recursion, this problem will just be so redundant, because consider these are not small number. Consider we are dealing with 4,000, 4 million steps, right? So it's gonna go down to 2 and 1, right? So meanwhile, these have been solved previously by this same algorithm when it's actually navigating here. Similarly, you will see that CS3 have been solved here, and again it's called again to be solved here, again called again multiple times to be solved. So because of that, we are gonna use a term that is called memoization, right? So this is it here, memoization. So whereby any problem that is solved, or let me say any sub problem that have been solved, will be saved, will be stored in something like a hash set, so that instead of resolving it again, whenever we come across such a sub problem, we can just go check in the hash set if it is there, and if it is, we just return the solution, the answer. So instead of having to solve it again, right? So we are gonna be using a hash set. In fact, we are gonna be using a hash map. Let's use a hash map so that we can store it as a key value pair. So because we know the number of steps 4 have been solved, we are gonna store 4 as a key, and the solution, you know, like I said the other time, the solution is 5, right? Why? Because the number of steps that it will take, the number of ways in which you can take 2 steps is actually 2, while the one for 1 is just 1. Because of that, 3 is gonna give us 3. Why? Because 3 is going to be a summation of the number of steps that takes number of ways in which you can get to 2 steps, and number of ways in which you can get to 1 step, and number of ways for 2 is 2, 1 is 1, and because of that the sum is 3, right? So similarly, to get 4 now, it's gonna be 3 plus 2, because the number of ways to get to 2 steps is 2, and the number of ways to get to 3 steps as we just calculated is 3. So meaning that it is 5. So what we're gonna be doing is that in our hash map, we're gonna be saving the key 4 with the value 5, right? So that next time when we come across the problem again, we can just check it up in the asset in hash map in O1 time, in a constant time, instead of having to do it again and again. So this is how we'll be solving this problem. We'll be going into the code implementation now for more better understanding of how to solve this problem. Alright, let's go into the code implementation for the climbing stairs DSA problem. So we'll be defining the function as climbing stairs, right? And it's gonna be giving us we're gonna be taking as arguments the number of steps that the staircase have, right? So which is an integer, right? So and what we're gonna do is that I want to return the total number of ways in which you can climb this stair. So it's also an integer. That's why you have this integer return type, right? Okay, so right here is the parameters we'll be needing. We want to calculate how many times and how many ways in which you can climb a staircase of 5 steps. So n is 5, right? So now it's so simple. This problem is actually simple, and thanks to DP, the dynamic programming, make it more simple, and recursion, right? So now what we're gonna do is that we want to place the base case first of all, because the base case is where the work really is. Otherwise it will just keep going on and on into an infinite loop. But when we place the base case, once it can get to a base case, then we start to see a solution. So you know, the solution of the sub problem starts to what? Generate and provide, and you know, it starts to generate the solution for the main problem. So first of all, if n is equals to 1, so meaning that in a situation whereby the number of steps in the staircase is just 1, what we want to do is that we want to return 1. Why? Because that actually means that there is just one way to climb the stair, and that's just by taking a single step, right? But in a situation whereby n is equals to 2, what we want to do is that we want to return 2. Why? Because now there is 2 ways to navigate that staircase, either by taking 2 steps at once or taking 1 step and you have to take that one step 2 times, right? So that's the 2 way to navigate it. But in a situation whereby it is greater than 2, then we want to use recursion to solve it, right? So and what we now do is that we know that when it is greater than 2, we just want to do want to return climbing stairs of n minus 2 plus climbing stairs of n minus 1, or let me say climbing stairs of n minus 1 plus climbing stairs of n minus 2. Why? Because at any point at all, any step at all, we can only get there from the previous step or the previous 2 steps, or 2 previous steps. You can get there from n minus 1 or n minus 2. Why? Because according to the problem statement, you can only take a single step or 2 steps at a time. So even if it is the 100th step, we know that we can always get there either from the 99th step or 98th step. So if we can get an answer to the 98th step, that is the number of ways in which you can reach the 98th step, and we can get an answer to the number of ways in which you can reach the 99th step, definitely we already have a solution to how we can reach the 100th step. So this is how to solve this problem. In fact, simply this. But now you will see that like I explained in the code logic, we need a way to keep track of already solved subproblems. Imagine 100 now, whereby you might be having different, the recursion is gonna be too much, and sometimes we will be resolving and regenerating solutions to the same subproblem that we have solved. If you remember the logic whereby we have to solve for 4 steps 2 times, we have to solve for 3 steps more than 2 times, like 3 times, right? So because of that, we are going to be using memoization, which is just a simple technique that uses an hash map, right? So let's call this the memo hash map, right? So that will be helping us to keep track of already solved subproblems. So and what we now do is that we want to check that if n in memo, so in case if this particular key n already exists in the memo, or this particular step n is in the memo, then return memo of n. So instead of having to call the function, we don't need to do anything. We just have to return memo of n, because memo of n will be the solution to that particular step. For example, now if 3 is in memo step 3, then we know that 3 is the solution to 3, right? Because we can get to 3 either through 2 or 1, and that sum up to 2 and 1 sum up to 3, right? Fine. So we just have to return 3 instead of having to come and recursively call 2 and 1, right? So that's what this place does. So it's gonna call the function short and return memo instead, so to the previous call. So but in a situation whereby it is not there, we are not just gonna return, right? Before returning, we are gonna do some things. So in a situation whereby it is not in memo, it's gonna execute this function, but what we are gonna do is that we are gonna add it to memo so that it can be there next time. So memo of n is equals to climbing stairs, and then we can now simply return memo of n, knowing that memo that the solution to this subproblem is already in memo. So next time it try to find the solution to n, it's gonna find it in memo, and it's just gonna return it instead of having to regenerate the solution. So this is simply how to solve this problem. Now let's run it and see how it goes. So we are expecting value 8, right? Because 8 is the number of steps is actually 8. So this is it here, 8. So if we look at the logic for the code, the problem statement that was given to us, you will see that it's also 8. So let's look at it here. Okay, it's actually 5 because the input is 4. So let's change the input here to 4. So it's gonna be 5. Let's run it and see. Sorry, I will have to hash this one here because. So this is it here, 5. I'm gonna rerun it again. So this is it here, 5, right? So this is how to solve this problem. Very simple, I think it's quite simple. So and I hope you do understand as well. So if you do, kindly subscribe to my YouTube channel, please. If you don't subscribe, I'm gonna work better on my teaching practice. Thank you.